We're going to look at number word problems in lesson 107, and these can be kind of complex, but we're going to try to simplify this down a little bit. Let me start with the big picture by reading an example problem. It says the sum of the digits in a two-digit counting number is 11. If the digits are reversed, the new number is 27 greater than the original number. What was the original number? All right, a lot to look at there. The first thing I want to break down is, okay, it is a two-digit counting number, all right? Two-digit counting number. Let's look at that first. What does that mean? Well, that simply means that we know it has a tens place, and I'm going to use T for tens, okay? I'll put it this way. And a units place. So my number, I'm going to write it as TU. So say, for example, the number is 52. I have a number in the tens place, and I have a number in the units place. My tens place number is 5. My units place number is 2. We're going to look for the T and the U, but we know that it is a two-digit counting number. Counting number, whatever, just know that it's two digits, okay? If it was three digits, I would use H for hundreds, and then we would have to do something like find H, T, and U. So we're trying to find the tens place and the units place. That is my original number that I am looking for. Okay? So I'm going to put off to the side that we are looking for TU. All right, the tens place and the units place. All right, so we looked at that part. Now let's look a little further into this. It said the sum of the digits is 11. All right, well, what were my digits? Well, we can use T plus U equals 11. So the sum of the two digits, all right, so say, well, I'm not going to speculate, but my two digits, their sum is 11. So say my number is, okay, 65, all right, that could be a number. Well, my tens would be 6, my 5 would be my units number, so 6 plus 5 in a sense equals 11. That's what it's trying to get at. But right now we know the sum of the digits in the two-digit number is 11. All right, so now we've done that sentence. All right, check mark there. Then it says if the digits are reversed, the new number is 27 greater than the original. All right, so I'm going to call this part A. Part B is now we're going to try to assign some value. Our tens is always a value of 10, at least. Well, it's 10 times whatever T is. All right, so I had that number 65 there earlier. Well, if 6 is T, then 6 times 10, 6D would be the value. Hopefully you kind of followed that, but 10 would represent the value of T. So I could say 10T plus U. All right, you could say 1U if you want, but that's irrelevant. So that is my original, or I'll call that the original. Now it says it reversed, okay? When the digits are reversed, the new number is yada, yada, yada. Okay, let me first define what reversed means. Reverse means, okay, 10 and 10 and 1 for the units place stay the same, but the letters switch. So when the letters switch, that's known as reverse. So now it's 10U plus 1T. All right? So those are my three things here. This is the sum. This is the original. This is the reverse. So now let's try to plug in what we know. Okay. So we say the sum of the two digits, yada, 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 is 11. All right? So that's the first part. That's not actually part of the overall equation. Then it says if the digits are reversed, the new number is 27 greater. So let's look at the new number Is always means equals, okay? Is 27 greater than the original? I'm going to put my original, all right, what does original represent? Right here, okay? 10t plus u plus 27, since it's 27 greater than the original. Okay, and it says that equals the two digits reversed. So 10u plus t. So the new number, okay, is, all right, the new number represents reversed. Okay, that's reversed. It is 27 greater than my original. What was the original number? Okay, so now we get to this point, and what we can use is substitution with our original sum here. So I can subtract u from both sides and have t equals 11 minus u. Or I could do u equals 11 minus t. Either one. I'm going to go ahead and do this one the way the book does it, so they plug in for u. All right. So they plug in for u. They plugged in for, yeah, they plugged in for u. All right. So they left 10t plus 11 minus t. All right. We plugged in for this u plus 27 equals 10. 11 minus t plus t. So now we're at an equation. We have one variable, erase that part, and we can solve. So 10t, I can just erase these parentheses overall. There's no negative outside distributing. So 10t minus t, that's 9t. 11 plus 27 is 38. 10 times that is 110 minus 10t plus t at negative 10, so that's a negative 9t. Keep solving. $18 equals 110 minus 38 is 72, or 18t equals 72. All right, so yeah, that equals 72. So we finally figure out what t is by dividing by 18. T equals, what is that? 4. 72 divided by 18 is 4. So t equals 4. I obviously now know for, if I was to plug in 4 there, that u equals 7. So there's my tens place and my units place. So going back up here, for t, I plug in the 4, and for u, I plug in the 7. So my original number was 47, because once again, remember, we were looking at a 2-digit counting number, and we just really broke that number down into tens places and units places. The original number is 47. And that is how you do number word problems.